Well, hello, geometers and seekers of general truths. In this lesson, we will discuss parallel lines and perpendicular lines in an XY coordinate plane. So first, let's talk about parallel lines. Well, in a coordinate plane, two lines are parallel if they have the same slope. Now, if two lines don't have a defined slope, like they're vertical lines, then those two lines are also parallel. And we will see the proof of these two statements in a separate part of the lesson. In this part, I want to discuss what the theorem says, these two theorems say, and then also walk you through some examples of calculations. So the second part of this lesson, or the second main idea here, is the slope of perpendicular lines. So if you have two lines that are perpendicular to each other in an XY coordinate plane, then their slopes are opposite reciprocals of each other. Okay, so let me give you a quick example. Let's say you have two lines that are perpendicular. So let's say we know that L1 and L2 are perpendicular to each other. Remember, this upside down T means perpendicular. So if the slope of L1 is, let's say, 2/3, then what that means is that the slope of L2, meaning is the opposite reciprocal. So opposite here means positives and negatives. So this is positive, therefore the slope of L2 must be negative. And reciprocal means that we swap the numerator and the denominator of that fraction. So the slope L2 of line 2 must be -3/2. All right. So if you have two lines that are parallel, then their slopes are identical. And if you have two lines that are perpendicular, then the slope of one is the opposite reciprocal of the other. All right, so let us look at a couple of examples here. Tell whether the lines through these particular points are parallel, perpendicular, or neither. So line 1 goes through these 2 points, line 2 goes through these 2 points, and I'm going to use M with a subscript to abbreviate. The slope of line 1 is going to be the change in y, so 2 minus 3, this 2 minus this 3, over -1 minus 2. So this gives me -1 over -3, which we can simplify to 1/3. So that's the slope of the first line. The slope of the second line, M2, is equal to 0 minus 1 over 0 minus 3. Which is going to give me -1 over -3, which is equal to 1/3 as well. So in this case, the two lines that we have the exact same slope. That means they must be parallel. All right, example 2, same thing. A lot of good practice here. Slope of the first line is 1 minus 3 over 0 minus 1. So we're going to get -2 over -1, which simplifies to 2. The second line has a slope of -1 minus 2 over 4 minus 5. So that's -3 over -1, which simplifies down to just 3. Okay. So these slopes are not equal. They're not opposites, right? Because they're both positive. So these two lines are neither parallel nor perpendicular. All right, moving on, a couple more examples. The first slope is 0 minus -2 over -5 minus -3. So this gives me 2 over, this is really -5 plus 3 here. So this gives me -2, and this reduces down to -1. That's my slope. The other line, line 2, has a slope of 2 minus 4 over -2 minus 0. So this is -2 in the numerator, and then this is -2 in the denominator, and this turns out to be +1 as my final answer. Okay. And these two lines are in fact perpendicular to each other, right? And let's see why. They are opposites and they are reciprocal of each other, because the reciprocal of 1 is 1. Okay, so the number 1 is unique in that sense, that it is its own reciprocal. They are clearly opposites and they are also reciprocals of each other. So these two lines we can say are perpendicular to each other. All right, and one last example. The slope of the first line is equal to 5 minus negative 8, or 5 plus 8, divided by 3 minus 3, which gives us 13 over 0. And remember, anything divided by 0 is undefined. Okay, so this is a vertical line here that we're looking at. So just to be clear, this is a vertical line. Now M2, the slope is going to be 7 minus 7 over negative 2 minus 3. So this gives me 0 over negative 5, which is 0. And so this is a horizontal line. And remember we said before, let's go back to the second part of the definition, or of the theorem on slopes of perpendicular line. Horizontal and vertical lines are perpendicular to each other. Okay, so even here, even though one of the lines has an undefined slope, we can still make a conclusion about how it's related to the other line, namely that these two lines have to be perpendicular because one of them is vertical and the other is horizontal. All right, so there you have it. Again, we will see a proof of this in a different part of the lesson, but this is some examples that hopefully give you a better sense of how to determine whether two lines are perpendicular or parallel or neither.